Alright, we're moving on with Unit 2. We're still talking about the geosphere here. So we're in Chapter 2, Section 2. We're going to look at minerals. So what is a mineral? A mineral, there are 5 things that determines whether or not something is a mineral. The first is that it has to be naturally occurring. It needs to be a solid substance. It needs to have an orderly crystalline structure on the interior. It needs to have a definite chemical composition, so its makeup or what it's made of. And then it needs to generally be considered inorganic. Now, there are a couple of different ways that minerals can form. They can form from the crystallization from magma. So magma that's in the earth hardening and forming into this mineral. By precipitation, and I don't mean by rain or snow. When I say precipitation, it means that it's being formed from a solution of some object or some chemical in water, and that water is being dissolved away, leaving behind a solid substance. That's precipitation or a precipitate. And then we have pressure and temperature. So high temperatures, high pressures coming in, molding, and forming those minerals. We also have hydrothermal solutions. Hydro, you should know, means water. Thermal is heat. So hot water solutions. So similar to precipitation, but instead of water evaporating out of the solution, you have hot water actually molding it. Now there are several different mineral groups. We're going to talk about a few of them. The first one that we're going to talk about are the silicates, and these are all classified by their composition. So what they're made of determines which group they are in. So our silicates are made of silicon and oxygen. They may have other forms or other elements in there as well, but silicon and oxygen are the two. And we have what's known as a silicon-oxygen tetrahedron. Okay, and we'll look at that in just a minute. So the silicon and the oxygen, remember I said that 75% of the Earth's crust is made of silicon and oxygen. It's the basis for every silicate mineral. So let's take a look at that tetrahedron. This is what your tetrahedron looks like. You have silicon and you have oxygen. And the way that those form, when they form together, will form different types of minerals. So let's take a look at a couple of those. If you have a silicate structure that is independent, so that means there's no cleavage to this, it's just one solid piece, you have one independent tetrahedron, you have the example of olivine. Okay, it has this green tint to it. This is olivine up here on the top. Then we have single chains, so you have tetrahedrons that are connecting together at this point. This is the pyroxene group, and augite is your example. Right, here's your augite. And then we have the amphibolite or amphibole group. This is a double chain, so you can see now we've connected in more than one place. So we're doubling up here. And hornblende is your example. Now, they can form in more than just chains. You can have them form where they are in sheets. Okay, so where they're connected several places in large sheets. So we have biotite and muscovite. You can see those here. Those are what we consider to be micas. So they are very thin. They will fracture or cleave. They'll pull apart in very thin sheets. Then we have the three-dimensional work. So this is, you have a cluster, so to speak. So potassium feldspar, plagioclase feldspar, quartz. These are your really hard minerals. These are the ones that are three-dimensional. And you can see an example of quartz and potassium feldspar here. Another mineral group are the carbonates. This contains carbon, oxygen, and one or more metallic elements. So for example, a carbonate is CO3. So you'll have 3 oxygen and 1 carbon, I'm sorry. And you can see how those form different minerals as well. A third group are the oxides. These contain oxygen and one or more other elements, usually a metal. You can see several examples here. You can see the oxides also will form clusters similar to the silicates. A fourth group are sulfates and sulfides. These are really two different groups, but we're going to stick them together because they both contain sulfur. Now, if you know anything about sulfur, sulfur is very distinctive by its smell. Sulfur tends to smell like rotten eggs. Now, that does not mean that sulfates and sulfides will smell like rotten eggs. Sulfur itself is what smells. But these are a few examples of sulfates and sulfides. Other mineral groups, we have what's considered to be the halides. These contain a halogen ion, so something from group 17 on your periodic table, and then one or more element. So a halide, for example, if you think about table salt, that's sodium and chlorine. Chlorine is a halide, it's a halogen ion. So table salt is a halide. And then the last group are your native elements. So these are minerals that exist in relatively pure form, all of which are going to be metals. So we have osmium, chromium, nickel, gold, and palladium. Those are your examples. And again, all of these exist in a relatively pure form because these can be mined. And that's it for today.